Hey there, welcome back. Today we're going over the exercises for lesson 1.4x. You can find these exercises on my website. The link is in the description below. So if you haven't done them yet, please go download the worksheet and try out the exercises yourself first, and then come back here and we can continue the video together while we answer all of the questions so you can check to see how you've done. Okay, well, if you're continuing, I assume you've already done the exercises, so we're going to start right now. Okay, here we are with question 1, and question 1a states that you have a leaky faucet at home. It leaks at a rate of 1 milliliter per second. How many liters of water are wasted after 1 month? We're assuming a 30-day month of constant leaking. Okay, so I want to write down what our target is. What we're trying to do is find how many liters of water are wasted in a month. Okay, so that's our target right there. Okay, now what do we start with? We start with a leak rate of 1 milliliter per second, and we need to get it into liters per month. So first, let's convert out the milliliters into liters, and we're going to need our conversion factor. Now we want milliliters in the denominator, right? So that will cancel right here. And so that means we'll have liters in the numerator, and we know that there is 1 liter for every 1,000 milliliters. So that's going to be our conversion factor, right? This is all equal to 1, so we're multiplying by 1 here. And when we do that, we're able to cancel out the milliliters and replace it with liters. So now we have liters in the numerator. Good, okay, that part is done. Now we need to get seconds into months. So how do we do that? Well, we have a few steps to get there. The first thing we'll say is there are 60 seconds in a minute, right? So we put the seconds in the numerator here so that it can cancel here with the seconds in the denominator. And now we have converted seconds into minutes, so we're on the way. We also know that there are 60 minutes in an hour, right? So this is going to allow us to get rid of the minutes, and now we've converted that into hours. But we want to get to months, so we have 24 hours in a day. That gets us up to days now. And finally, we said that there are 30 days in a month. So that will allow us to cancel out the days, and we're left with months in the denominator, which is what we want. So now we can simply plug everything in, and let's get our calculator. Okay, so what do we have? We have multiply all the numerators first. That's 1 times 1 times 60 times 60 times 24 times 30. And that is all divided by 1,000. That's the only thing we have in the denominator. So 2,592 liters per month. So you got a leak, drip, 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 1 milliliter per second. That adds up to almost 2,600 liters of water down the drain every month. That is a lot of water that you're losing. Part B here asks us, water costs $5 per cubic meter. There are 1,000 liters per cubic meter. How much money would you save in a year if you fixed the leaky faucet? Okay, so again, like before, I want to write down what our target is here, just so we have that there nice and clear, and that's going to be dollars per year, right? That's what we're looking to convert everything into. Okay, we start out with essentially our answer from part A. That's 2,592 liters per month, right? Now, if you had rounded this to 2,600 or something, that's fine. You'll get an answer that's close enough. Okay, so how do we convert this over? Well, first we can convert the months to years. That shouldn't be too hard, right? So we know that there are 12 months in 1 year. That will allow us to cancel out the months. And now we've gotten the year in the denominator, so that part is done. Now we need to convert liters into dollars. Okay, so looks like dollars are given here in terms of cubic meters, so we'll have to convert liters to cubic meters first. And we see that there is 1,000 liters per cubic meter. We want the liters to be in the denominator, right? So that we can get them to cancel out here. That's the goal. So we say that there are 1,000 liters in 1 cubic meter. And then we can cancel the liters just like that. And now we can finally use this conversion factor. And we're going to convert cubic meters into dollars, right? So we'll have $5 for every 1 cubic meter. We could write a 1 here if we wanted to. And that'll cancel out the cubic meters, leaving us with dollars in the numerator, which completes our goal. And so now we can simply plug in the numbers, right? I should have kept that. 2,592 times 12 times 1 times $5. And that's all over 1,000. All right, there we are, $155.52. If you had $155, that's fine. If you started out with 2,600 here, you probably got something closer to a couple dollars more, maybe. That's fine. But what we're looking at here is a savings of $155 if you fix this leaky faucet. Or, conversely, if you don't fix this faucet, you're literally flushing $150 down the drain every year. And that adds up. So, tip of the day, if you've got a leaky faucet, you should fix it. It's going to save you money, and you should give my video a thumbs up for this extra great money-saving tip. Okay, let's move on to question 2. Your favorite can of soda has a volume of 543 milliliters. What is its volume in cubic inches? And we have some conversion factors here. 1 milliliter is the same as 1 cubic centimeter. 1 inch is equal to 2.54 centimeters. Okay. What do we need to know? We need to know the volume in cubic inches. That's the goal, right? And so just to note here, so 1 milliliter is equal to 1 cubic centimeter, right? These are the same volumes. And sometimes 1 cubic centimeter is written as cc, right? Not in physics usually, but sometimes maybe in like biology or medicine, give them 2 cc's of insulin or something. It's a cubic centimeter or a milliliter, all the same. Okay, let's get back to this exercise here. So we're starting out with 543 milliliters, and we need to convert that into cubic inches. Okay, let's go ahead and do that. The first thing we want to do here is probably convert it into cubic centimeters. We have this conversion factor here. So we see here that it's a 1-to-1 ratio, right? So 1 cubic centimeter is the same as 1 milliliter. And we put the milliliter in the denominator so that we're able to cancel this out. Great. Now we have cubic centimeters, and we need to convert that into cubic inches. So how are we going to do that? All right, well, we know that we want the centimeters in the denominator. So we're going to say here 1 inch is the same as 2.54 centimeters. Okay, now this is centimeters to the power of 1. This is centimeters to the power of 3. So what do? Well, we have some options here. If we just do it like this, then we would cancel out this centimeter with one of these. So this would be now centimeters squared. We want to get rid of all of those centimeters, right? So one option would be to repeat this a few times. You could do multiply again by 1 inch per 2.54 centimeters. And then do it again, right? 1 inch per 2.54 centimeters. So here you would have a centimeter, 3 of these, right? And that would cancel out all 3 of those, and then we would end up with inches cubed in the numerator. So that's one way we could write it. Obviously, it's a little bit long. So usually what we do is we just cube the conversion factor here, and it accomplishes exactly the same thing. So let's write it down this way. And now all we have to do is do the math, because we've got cubic inches now in the numerator, which is what we're looking for. Okay, so what do we have? 543 times 1 cubed divided by 2.54 cubed. So I'm just going to divide by 2.54 3 times. 2.54 divided by 2.54, and we get 33.1 cubic inches. All right, so there we go. That's the answer here. And you know what? I'm just going to highlight it, make it easier to find. That's our answer here. And for the first one, I'll do the same thing just to make it a little bit easier to find. Okay, there we are. That's the answer to question number 2. Let's move on to number 3. All right, question 3. The density of iron is 7.8 grams per cubic centimeter. What is this in kilograms per cubic meter? Okay, so our goal here is to get it in kilograms per cubic meter. That's our target. And what do we start with? We start with 7.8 grams per cubic centimeter. Okay, so what do we want to convert first? We could go for, let's convert grams to kilograms first. Okay, that shouldn't be too bad. We know that there is 1 kilogram for every 1,000 grams, right? That allows us to cancel the grams out. So now we've got kilograms in the numerator, halfway done. Now we need to convert cubic centimeters into cubic meters. And it's similar to what we did in the last problem. So we know that there are 100 centimeters for every meter. And now if we cube this, we will get the centimeters cubed in the numerator that we can cancel here. And that'll put meters cubed in the denominator. So we're done. Right? We can now solve this and plug the numbers into our amazing scientific calculator. We've got 7.8 times 100 cubed. I'll just times 100 times 100 times 100. And that's all divided by 1,000, 7,800 kilograms per cubic meter. Our answer right there. Okay, pretty good. Okay, iron it's pretty heavy, 7,800 kilograms in 1 cubic meter. For reference, if this was water, 1 cubic meter of water is 1,000 kilograms, right? So iron is almost 8 times more dense than water. Okay, question number 4. A neutron star rotates 500 times per second. How many rotations does it complete in a year, assuming 365 days for a year? So neutron stars are these very, very compact stellar bodies. They used to be very large stars, but they've sort of blown off their outer gaseous envelope. They've gone supernova, and what remains in the middle is a very compact entity, sort of almost completely made of neutrons. And because the material has collapsed down so much. Conservation of angular momentum allows it to rotate faster and faster and faster until it's rotating maybe up to 500 times per second, which is crazy fast. So cool. Okay, what are we looking for? We're looking for rotations per year. Okay, and we start out with 500 rotations per second. Okay, so we really only need to convert one thing here, and that's seconds into years. And that shouldn't be too bad. We've done stuff like this before. Let's go through it. Okay, so we need to get seconds in the numerator, right? So we'll say there are 60 seconds per minute. And that allows us to cancel out the seconds and change it into minutes. And then we also have 60 minutes per hour. Canceling out the minutes, getting us hours. And we have 24 hours per day, canceling out the hours and getting us into units of days. And then we have 365 days per year. And that will cancel out the days and leave us with years in the denominator, which is what we're looking for. Rotations already there. We're done. Okay, let's just plug this in now into our calculator. And what do we get? 500 times 60 times 60 times 24 times 365 equals, wow, that's a big number. Okay, 15.7 billion rotations in a year. Now, I prefer maybe to write this in scientific notation. So in that case, it would be 1.57 times 10 to the 10 rotations per year, right? But if we were using prefixes, what would this be? How many rotations would this be? Well, this would be 1,000 rotations would be a kilorotation, right? 1,000,000 rotations would be a mega rotation, and 1,000,000,000 rotations would be a giga rotation. And so this could also be written as 15.7 giga rotations per year. Not a very standard unit of measurement, but it works. So that answers question number 4 here. Okay, I hope you got them all correct. And if you didn't, I hope you see where the problems were as we reviewed them just now. If you still have any questions about this, leave a question in the comments below. And you can sub to make sure you get more content in the future. And yeah, keep checking that website. I'll be putting more lessons, more videos, and more exercises up there for future topics. Thanks a lot for sticking with me so far, and take care. See you next time. Bye-bye.